Good morning, everyone. Thanks for joining our live stream this morning. I have our presenter, Terry Becker, here with me. And the primary objective of this live stream is to ensure that we drive or bring awareness to electrical safety program, one of the things that's not have a good visibility in the industry. So Terry Becker is the presenter today, and I'll be asking him some good questions about electrical safety program and how does really the safety programs help you guys to do a better job at your facilities when working with your qualified electrical workers or task qualified workers and such. Just want to give a quick introduction about Terry. I know Terry Becker for about 5 years now, since I met him first time at one of the electrical safety workshops in the past, like 5 years ago. So Terry is a PE professional engineer, and he's a certified electrical safety compliance professional, and also an IEEE Senior Member. He's an independent electrical safety specialist and a consultant at TW Becker Electrical Safety Consulting Incorporated. 6 months or 7 months ago, Terry and we connected together, and he's partnering with Grace Technologies and rolling out our Grace Expert Network Services program. So Terry was a previous owner and visionary of electrical safety programs, Solutions Inc., and spent about 10 years growing the company industry leading solutions. So Terry brings more than 29 years of experience. So what I know about Terry is only 5 years, but Terry brings in 29 years of experience as an electrical engineer, working in both engineering consulting and for large industrial oil and gas corporations. He's also a past vice chair of the CSA Z462 Workplace Electrical Safety Standards Technical Committee, and is currently a voting member and a leader of working group for annexes and clauses 4.1 of CSA Z462. So apart from 29 years of the total experience what Terry brings in, he has experience for about 13 years as an independent electrical safety consulting field as well. So Terry is also a voting member of 1584 standards for performing arc flash hazard calculations, and voting member of also CSA Z462. This is a broad introduction about Terry, and then I would like to ask Terry to give the introduction from his side, asking a few questions. The first is, what really got him into electrical safety, and why he is so passionate about electrical safety. Terry, it's all yours, Terry. Go ahead.
Bhanu, hey, thanks for that introduction, and really appreciate you hosting this live streaming event today. How did I get into electrical safety? And I think my story may be similar to many others out there. You mentioned my background's electrical engineering. I'm based out of Calgary, Alberta, Canada. My previous employment before doing pure electrical safety consulting was an electrical engineer in large oil and gas companies and engineering consulting related to oil and gas. So I was thrown into that back in 1991 when I graduated from university. And it was standard electrical engineering, power projects, control projects, PLCs, Canadian local code compliance, your standard sort of large industrial company. And so, yeah, I started there in 91 and I traveled through different jobs. And in 2005, I went to a conference, which was the IEEE Petroleum Chemical Industry Committee Conference, which is part of the Industrial Application Society, where now I know that the IEEE Electrical Safety Workshop exists. But at that conference, there was a presentation on the NFPA 70E, the 2004 edition. Well, of course, we now have the 2021 edition, but back then was this edition, right? I actually found a copy, right? So this is it, because I've got all the hard copies, right? So the presentation was on this edition, and arc flash, the topic of arc flash came up. And now remember, this is 15 years ago, right? So I said, what is an arc flash? I was compelled, and I'm going, wow. I think you probably showed some videos. That's sort of the standard. And the shock word came up too, but the presentation had a lot of arc flash in it, the 04 edition, the hazardous category tables and all that. I came back from that conference, and I don't know, I guess, forgive the analogy, but a switch turned on, and I said, we've got a big problem. We've got an identified hazard that's not identified in the workplace within our company. And at that time, I was working for Encana Corporation, which was a very large natural gas producer and oil producer. And I was in a senior staff electrical engineering role, and my job was to manage the company's risk related to electrical anything, right? Capital projects, maintenance, code compliance. And all of a sudden, I realized that there was another obligation that I had to deal with, which was protecting electricians. And as I found out, other task qualified workers from these two hazards. So I approached my manager. My manager said, "Hey, do your job, take care of it." So that started me down a path, and it's been a really interesting path. My career path changed, and it refocused me within that job. I became the Canada Electrical Safety Program Manager. And as we have this live streaming event, we'll talk about electrical safety programs, but I didn't know what that meant at the time, but that's what I ended up becoming by 2007. I was the key contact within our organization. There was other electrical engineers on staff, but we just divided up the responsibility, and I raised my hand and said, I want that role. So I was driving this, and that's another topic within employers, is someone needs to grab onto this topic. So, but I didn't. But going backwards again, I didn't know what an arc flash was. I knew what a shock was, right? But I really didn't maybe understand even shock in the workplace. And I want to make sure today that we talk about shock, and I know we will. But right now, let's talk about where I ended up going from 2005 until today. So I grabbed onto it. I did some benchmarking. Right. So I did some benchmarking, and when you get into making any type of business decision, you got to do some homework and research, right? So I benchmarked against our peer oil and gas companies, and there was some pretty major U.S. players, Shell, ConocoPhillips, some other players, large Canadian oil and gas companies too. And we had a peer network of electrical engineers, so I knew 20, 30 of my peers, and a couple of the U.S. companies like Shell and Conoco, they had some stuff, they had some documentation. But even what I reviewed later on for those organizations wasn't an electrical safety program, because electrical engineers were involved. The documents that were evolving were more technical specifications. So I was getting information, benchmarking what we need to do, and said we need to, first of all, identify these hazards properly, effectively, underneath our existing occupational health and safety management system. And we had an exhaustive occupational health and safety management system, thousands of workers every day across Canada and US exposed to workplace hazards. And, things were pretty busy back in 2005 plus. So I figure at that time, I think we had 200, 300, 400 electricians every day potentially doing a low voltage measurement, diagnostics or troubleshooting, or absence of voltage. So when I looked at the liability, and the other words that come up all the time is due diligence to OHS regulations, we had significant liability. And at that point in time, no one had identified arc flash. No one had identified what arc flash PPE was. Now, it was the oil and gas industry, so we had flame-resistant coveralls on every worker because of the flash fire hazard. So, I knew what a flash fire was, an exposure, because I was wearing the PPE when I was on the sites, but I had no idea what an arc flash was. So I went through this whole discovery process of trying to understand what arc flash was, trying to make sure I focused on shock, but I was overwhelmed by arc flash, like I think everybody is. And then, and so I said, okay, what's the PPE? And I went to, our vendors and said, we got these flame resistant coveralls. Are they arc rated? The vendors in Canada didn't even know what arc rating was. No surprise, because no one was asking. I had a pair of coveralls that did not have arc flash labeling on the label at that time because the vendors didn't add it. That's all changed, of course. So it was exploratory discovery, get educated. And as I was getting educated, sort of my passion for the topic started to evolve. I realized that there was significant requirements here to sort this out. And I was learning, and I'm still learning today, right? So I started learning back then about electrical safety, arc flash and shock. I found out about the IEEE Electrical Safety Workshop, probably because of the PCIC conference and the link between the two. And I went to my first ESW in Denver in 2006. So remember, I went to the PCIC in 2005, found out about the Electrical Safety Workshop. And when I went to Denver, it was like unbelievable. I was at, this place where there was all these people and many, many passionate folks. Everybody was there trying to find out. And I started to meet some other folks. One of them was Lanny Floyd with DuPont. He's well known in the arena. Ken Mastrello, he was with NFPA. Like, there was a raft of names I could just list off that I became inspired. They were doing presentations. So again, 2005, 2006, and I'm trying to evolve this at Encana Corporation. And it was a big machine, right? So that's the other challenge. The bigger the company, the more difficult it is to try and get change to occur. But I worked through it, and in 2007, I felt that I had one passion. I developed some electrical safety subject matter expertise, and I'd taken in Canada to a certain point in time that I made a change in my career, and I formed my own small engineering consulting firm, ESPS Electrical Safety Program Solutions Inc. And then that took me down this path of the last 13 years. And I named the company with a solution that is still not present in industry, which is electrical safety programs and solutions, right? So the electrical safety program, as we go through this live streaming event, and I'm going to keep saying it over and over again, is companies need compliant electrical safety programs. So I left. People said, "You left that job? That job was amazing, right? You were making all this money and you're working for this premier high profile oil and gas company." And I said, "Well, yeah, but I can help other people sort this out." And that was the challenge. I spent 2 years trying to figure it out, and I hadn't even totally figured it out at that point, but I had enough, background information, or what I felt was subject matter expertise. So at the same time, and this is sort of strange, but I wasn't the only one in Canada that was looking at arc flash and shock. The Canadian Electrical Code came out with a new rule in 2006, Rule 2306, which requires a minimum arc flash and shock equipment label on a certain list of electrical equipment, a basic label. That's it. Warning, arc flash and shock. So there was some convergence. It's sort of crazy when I talk about it. There was convergence because I phoned the CSA, the Canadian Standards Association, and I said, "Hey, are we going to do something about?" Or first of all, I had to ask her, "Do you know about arc flash and shock hazards?" And of course, the initial response was, "Well, what do you mean? What are you talking about?" I said, "Oh, NFPA 70E, right?" And it was the 2004 edition again, right? So I said, "Well, what about this document? You guys aware of it?" And CSA said, "Well, ironically, we are, right?" So there was some convergence with the Canadian Electrical Code, and Canada has another standard called Z460, Control of Hazardous Energy Lockout and Other Methods. So that tech committee somehow got 70E on the radar screen. And then they contacted me later in 2006. They said they've signed an MOU with NFPA to harmonize standards for North America. And a lot of people don't know this history of the CSA Z462 Workplace Electrical Safety Standard. And they said, "Terry, do you want to be the first vice chair of the technical committee for Canada's arc flash and shock standard, or workplace electrical safety, Z462?" And I, of course, said yes. It would be advantageous for my company to be involved, being one of Canada's largest oil and gas companies at that time. And I brought Shell and Husky along with me to be members of Z462 initially. So I am the first past vice chair, and I got involved. I've attended every one of those meetings ever since. As well, I became educated about 70E. So I found out that I could attend the NFPA 70E tech committee meetings as well. And I attended my first 70E meeting in San Diego in 2007, which was unbelievable. I was blown away, right, by the organization, the structure, the history, the amount of work that had happened on that standard. And I, again, networked with a whole bunch of people. And my passion in was growing as I'm going through this storyline with you. So again, I left in Canada, formed my own company, got involved in standards. Z462 is constituted. Z462 just published its 5th edition, January 5th, 2021. We always lag behind NFPA 70E, which published in September, but it's the 5th edition, right, for Canada. And I'd have to say in the last 13 years, there has been a lot of benefit, extreme amount of benefit to Z462 being published and getting rolled out across Canada. But there's always a but. There's been a lot of challenges since then, a lot of misinformation, a lot of myths, right? And we have a lot of work to do. So 13 years later, 2021, in Canada, 5th edition of Z462 publishes, but there's problems that industry needs to understand and take control of, and they need to take control of arc flash. So Bhanu, again, that's, and you know me, I could talk for a long time. I've got a lot of good stories along the way, but I think some of those stories, and they're not stories, they're experience, right?
Good, right.
Experience. And knowledge gained, and then becoming another word I'll use is electrical safety competent. So I think I'm electrical safety competent, right? I quote, I'm an electrical safety specialist, but I think I'm electrical safety competent in understanding, a broad stroke of what we can do and then narrowing it down into the hierarchy of risk control methods. And that's another evolution of 70E and Z462 is moving from pure hazard ID PPE to full-on risk assessment procedure. So along the way now, lots of benefit, but I also think that I know that arc flash has taken on its own identity, and that's been proliferated by issues that hopefully we'll talk about some today, and maybe we'll get some questions coming in. But the solution is an electrical safety program, applying the hierarchy of risk control methods, and applying them so that you understand that they're working, right? And you do that through a defined management system and ensuring the workers that are exposed, qualified electrical workers, task qualified workers, can be successful, right? Successful in achieving risk reduction to themselves, right? So you and I have talked about this, that electricians today, after this whole evolution, in my timeline, in the US, and this is a global issue as well. So there's the challenge. Since I started this has taken off. So I've presented 5 times in Australia at conferences, right? And I've probably presented, I don't know how many times in the US at the ESW, the PCIC. I presented in workshops and conferences across Canada for different associations. But it was a telling story when I went to Australia and presented at a conference down there, talking about what was going on in Canada. That was my presentation, and that we adopted 70E. And that this topic of arc flash is still a long, long way from being managed globally, right? Electricity has enabled our society. It's continuing to enable our society, and our use of electricity will grow, not decline, right? And therefore, we're going to have the need for more qualified electrical workers, task qualified workers, to construct it, commission it, and then maintain it. And I'd like energized electrical work, I'd like to eliminate exposure, but we'll never eliminate exposure, right? It's not going to happen, right? So, and we need to deal with the myths and misinformation. So anyways,
Before you go too much into the
Yeah.
discussion, I would like to ask you a few things and give the audience who is watching this live stream about you guys might be wondering why Grace Technologies is in this expert network program. So I just want to give you a quick background and overview. So Grace has been in this electrical safety business for over 2.5 decades. And we have this electrical safety by design products like Grace ports and voltage indicators, then the safe test points for verifying absence of voltage, test from outside the door and all. These are the things more like eliminating or engineering controls that can be used in most of the equipment which our customers use. But the bigger thing, what really got us into electrical safety expert networking spaces, specifically when we go and have these conversations with our end users and also with a lot of the OEMs, the one thing that's a common theme we see around was basically they all understand the product level, what it does, but no one had a good, clear idea of the overarching theme of the principle around why these things exist in first place. So they had this health and safety departments, and then they had this electrical safety department, totally 2 independent organizations working on their own silos, and there was no proper alignment. So that was a constant theme. And then when I was talking to Drew, who is our current CEO at Grace, about this a year ago, and he was like, it would be a good idea for us to come up with network services where we can scale this program and get our customers or the end users with a templated version of what people can do on a regular basis without the need to go through all this amounts of data, glancing through the documents and reading through all this, right? So again, to add to that, whenever we go and ask about, do you have electrical safety program to our end users, the first thing is, we sent our people for safety training, and then we bought a bunch of PPE. So that's kind of what the feedback we heard. And then that basically got us back into a question okay, so having just a PPE and then sending your personnel to electrical safety training does not complete the electrical safety program. And because, again, the safety is tuned around both the products, policies, and procedures, and the management system. I think Terry can talk in detail about that. So basically, Terry, why do you think electrical safety program is such an important thing when it comes to overall safety, because there is the safety department, they work on the general safety, and there is electrical safety, right? So why do you think this having a sound and well-rounded safety program is critical for the success of an organization?
So Bhanu, your comments stimulate this quote I'm going to make, is that employers have been implementing bottom-up controls, and it's the wrong order, right? So this is my experience. I told you, what did I do first? I looked at PP first when I was back working for Encana, right? Why did I look at PP first? I don't know. I just did. But what's happened is that's a bottom-up control. In the hierarchy of risk controls, PP's last. But industry has been incented to look at arc flash PP first. And then shock PP. Remember, I told you we got to make sure both these hazards. But arc flash, oh my God. You know, and I saw these videos. So then they phone a PP vendor. And then, you know, the large OHS PP vendors sell thousands of products. So you get a salesman on the phone and he knows that they've got HRC 2 and 4 kits. Well, what do I need? Well, you need these kits. You know, give me $5,000 and you can have these kits per worker and your problem solved. Well, no, the problem's not solved because, first of all, in the PP, they just accepted what the vendor was providing them. They didn't provide the vendor with a specification that they control because they didn't have an electrical safety program. Then the training, so if we go from the bottom of the hierarchy and work our way up, it's PP, then it's administrative training and procedures, which is the next one up. So then, well, we need to send all of our electricians on training, arc flash awareness training, arc flash training. And that's the first way that I know that training's not compliant, when the title of the training doesn't include the word shock, right? But it's marketing, right? So then all of a sudden, well, you know, I've heard about getting these labels. We need to get these labels on our electrical equipment or else we're not compliant, right? So that's a higher order control. That's engineering, safety by design. But ultimately, what you're achieving out of that is a lower order control. You're getting a warning or danger label on the electrical equipment, right? So the hierarchy of risk controls is elimination, substitution, engineering, safety by design, warning signs and barricading, administrative controls, training procedures, and PP. So now we hire an electrical engineer and we spend a lot of money because we need these labels, right? Now remember, the NEC Article 110.16 has a minimum label as well, but it's a minimum label. It says warning arc flash. It doesn't even have the word shock on it as well, which is a problem. That it just says arc flash, arc flash. So this is the historical problem. Bottom-up controls, PP vendor sells me an HRC 2 or 4 kit, which would now be an arc flash PP category 2 or 4 kit. There's rafts of training out there, arc flash awareness, arc flash training. There's other training that's called arc flash and shock or workplace safety. And then I hire an engineer because I need these studies. And then along the way, the employer is being, I guess, conditioned to the fact that that's what they need to do. They need to pay for a very expensive study with no technical specification. These have been blank checks to engineering consulting firms and electrical equipment manufacturers that in their engineering departments have proliferated pushing these studies on industry and pushing these studies. And I'm a professional electrical engineer in 5 provinces up here, so I can speak for it. I've actually reviewed arc flash hazard incident analysis studies from firms from BC to Newfoundland and Labrador. And that's over the last 10 years. And as far as that topic, these studies that the employers are relying on, I'll be blunt with you, there's been lots of errors and omissions and misinformation in those reports. So this is the history of the last 10 years. I did it. I bought PP. I phoned our engineering consultants, and this is 13 years ago in Canada. We had 40 engineering consulting firms doing work for my company, my oil and gas company. That's how busy we were. I took the top 20. I knew what the answer was. I phoned them all and said, do you guys know anything about arc flash? Of course they said no, right? That's 15 years ago. I said, can you get the arc flash module for the software? They said, what? There's a module? So 15 years ago in Canada, there was no arc flash hazard incident analysis studies. In 15 years, I'm going to quote a stupid number, but I guarantee you there's been $100 million or more, probably more, spent on these studies with reports issued to the clients that misinform them, have errors and omissions, and the arc flash and shock equipment labels, unbelievable. I've seen labels that my jaw drops, and I don't know why the employer is not taking control. I just don't understand it. So this is the history in Canada and in the US and globally, because PP is easy, isn't it? I'll just phone someone, I can get it. But without understanding what the PP is, and not specifying it, buyer beware. Like everything. My dad said, if you pay cheap, you're going to get cheap. If you pay for quality, you're going to get quality, right? And quality will last, right? So that's another topic about PPE. There's a lot of PPE out there over the years, right? And even today. But the PPE, the good thing is the demand increased and there's been evolution, right? So there's been evolution in the PPE from 15 years ago when I first bought an arc-rated face shield for Encana and arc flash suits. And then electricians called them bomb suits, by the way, which was, they're not bomb suits, right? And if you want to wear a bomb suit as an electrician, watch the movie The Hurt Locker, where Jeremy Reamer is wearing a bomb suit, and you don't want to wear one of those and do electrical work. So their arc flash suits are fit for purpose. So bottom-up controls, lots of challenges, and we need to move through this. Employers need to take control, and they take control by having an electrical safety program that's compliant.
So that's a good thing, because since you talked about the PPE, I'm going to ask you a follow-up question, because most people think, or most facilities think, that PPE is the answer to all sorts of electrical safety problems, right? So you buy the PPE, you put it there, and that solves all the safety problems, whatever you have at your facility. I think that's one of the misconceptions, as you said, right? And then that comes with the price of what is the rating, what's the ARC rating of those PPE that you're wearing, right? So do they have the right ARC ratings of those PPE that's been defined for the specific task and the application? I mean, can you just elaborate on those things? Because I know that there is instances where there is like a 40 cal ARC suit requirement or 75 cal, but someone will be donning like 12 cal suit, and they think that they have a PPE, so it's going to protect them. So you want to expand on that, Terry?
Yeah, so this is a complicated discussion on PPE. It's not complicated. I guess it's just, like I said, even the PPE is taken on its own, its own identity in this topic. So you mentioned 40 calories per centimeter squared. And when I got into this back then, I did phone a PPE. Oh, well, we've got 40 calorie per centimeter squared arc flash suits. You need those. And I guess personally, I'm a lot more inquisitive. And with my engineering background, I said, well, I'm just not going to accept that. I said, give me more information, right? What's this arc flash suit? Is that the only one you have? Well, I found out very quickly, and this is 15 years ago, that there were other arc flash suits with arc thermal performance values. So what had happened is the HRC number, right? And that was 6 of them, 0, 0, 0, 1, 2, 3, 4 in this version of 70E, right? The 2004 edition. Right, so that's how PPE. So I phoned vendors. Well, we got HRC 24 kits, and I found 70E in the table, and it correlated to this value, right? The arc thermal performance value, and I'm going to focus on the 40 cal topic right now, because I said, well, why this 40 cal thing? Well, because the blast pressure is going to be so high, it's going to pulverize workers, right? It's going to just crush them. They're going to be instantly dead because the pressure impressed on their bodies, their chest. And I said, what? Right. So I didn't accept anything. So that was the other thing. I didn't accept these statements that I felt were over the top. And then when they were made, the person that made them didn't substantiate them. Right. So initially, the arc flash PPE, bomb suits, the 40 cal is dangerous, and no PP exists greater than 40.1 calories per centimeter squared. And this is where I said the bottom-up controls and the engineering studies, right? So the engineers were communicating to their clients in their results tables pushed out by the power system software vendors, 3 of them in North America that all did the same thing back then. They actually, in error, included a column in the results table, what I call the results table. So it's a report from the power system software. It's the arc flash hazard incident energy analysis calculations report. I call it the results table. Has multiple columns: equipment, protected device, whole bunch of electrical data, and then the incident energy, and then the arc flash boundary and the working distance. And then there was a final column, and the final column had these HRC numbers in it. It had 1, 2, 3, 4, and then it had, it set it off and said dangerous, no PP exists. So I'm moving through this. Remember 15 years ago, and I'm starting to get these studies done. I'm going to the IEEE Electrical Safety Workshop. I'm seeing presentations. I'm attending the NFPA 70 tech committee meetings, RZ462 meetings, and I'm starting to identify these issues. That was the first one on the PP. So the everyday wear, task wear, 8 to 12 calorie per centimeter squared world, well, that's easy. That's a shirt and pant, or 9% of the time it's a coverall with a shield, balaclava, right? ear canal insert earplugs, approved eyewear, and then leather, CSA approved, or in the US, EH approved footwear. And then you need something on your hands. So I quickly learned about that because we needed to get this sorted out. But like I said, I pulled the PP vendors, arc flash shoots, 40 cal, gee, stop, danger, danger. And then since then, I've advocated that pressure, this is 10 years that I've done this, is not what it's being communicated in the engineering reports, because the engineering reports would then embellish, and they never should have. The electrical engineering report is a report that should just report out incident energy at an assumed working distance and the arc flash boundary. Engineers don't get paid to take on additional liability. So the engineers that have proliferated, misinformation in their reports may be held accountable. But then, Terry, you're going to say, well, Terry, if they're promoting 40 cals or less, it's very conservative, right? Well, it is. So there's been misinformation about the PPE, specifically related to the correlation of incident energy to blast pressure, and there is no direct correlation. Blast pressure correlates to arcing fault current, as per Dr. Ralph Lee. He's an electrical engineer from Edmonton, Alberta, Canada, that did some of the initial research and came up with his initial empirical formulas back in the late 1980s. So I respect this man. He's a pioneer, a Canadian electrical engineer, pioneered arc flash incident energy calculations and blast. So his blast research is still published today. And there's a graph from his research that shows that blast pressure correlates to arcing fault current, does not correlate to incident energy. So arc flash suits are available up to 140 calories per centimeter squared, right? And they've been available for over 15 years with that arc thermal performance value, right? But the market pandered to the 40 cal myth. Some companies didn't. They said, well, no, we're going to have other options, right? And other options, because some companies did figure it out. They figured out that 40 cal wasn't a stop point, that we can have workers working safely with residual risk managed. And I'm using new language, right? I'm using new language from, these later editions of 70E about risk assessment, so that when you do a risk assessment, the 40 cal myth gets just totally off the table, right? So, and then on top of that, like I said, electricians call them bomb suits because they were they were knitted and very, very thick, right? Very bulky. But the clothing technology. So thankfully, the vendors of the cloth and the fabricators in the last 10 years have brought out arc flash suits that are unbelievably comfortable. They're extremely thin. The physical weight, the physical ounce weight per square yard, so the physical weight on the worker has been reduced significantly. You don't even know that you're wearing an arc flash suit now, as far as the jacket and the bib overalls, because the total layering, right, to achieve a total system arc rating, is unbelievably lightweight, very thin, and very, very, very pliable, like flexible when you wear it, right? So just give me a second, so I'm going to grab something.
Sure.
This is the 140 cal arc flash suit, right? Now, if you look at this, right, it's a jacket, right? And if you haven't ever seen a 140 cal arc flash suit, you can go, geez, Terry, that doesn't look that bad. That doesn't even look as thick as these historical 40 cal suits that were these massively thick, very, very warm to wear jackets, right? So this is the evolution of the technology. This is 140 cal per centimeter squared AT arc flash suit with bib overalls and a hood, right? So the PP should be specified by the employer in their electrical safety program. Take control. So again, get educated, understand what this PP is, and don't be right narrowly minded going, well, the engineer's report said 40 cal is dangerous. It's not. And the word dangerous was incorrectly leveraged by the software vendors as an automatic. So these reports were generated automatically, right? So 40.1 calories per centimeter squared, the software would put in the column, no PP exists. Now that's changed, by the way, because I complained to the software vendors. Others did as well, but I'm just a small voice. I don't have a big, logo behind me. So I got other people involved and this is my network. So I've got a strong electrical safety network. I personally know, well, Bhanu's part of that network, right? A lot of people that are doing this right and will influence it, but there's a lot of people out there that aren't in that position. So the PP, Bhanu, we could talk just for 2 hours more, but that's the arc flash suit discussion, but it relates to now the risk assessment, and the risk assessment procedure currently in 70 and Z462 is another challenge, because I think a lot of the training, the trainer at the front does not talk about the risk assessment procedure because they don't understand it.
I'm going to quickly interrupt there and ask you a question, because as you know and I know, so there's a lot of research has been done around arc flash and arc blast, but very minimal research done around shock hazards. Why is that? Why shock hazard does not get that level of visibility when it comes to electrical safety? Like, people are all talking about what will happen if there's an arc flash incident, right? So no significant work has been done around the area of shock hazard. And we both know that there's a lot of shock incidents than the arc flash in the reality, right? So how do we change this to get this more visibility on the shock hazards? Do you want to elaborate on that, Terry?
So again, now you brought up another topic, and the shock hazard, statistically, we know that that's actually the problem, not arc flash. When I say the problem, right, that shock is actually historically and statistically where we've had the injuries that haven't been reported, and then we've had the fatalities. And shock's exposure for all workers on a work site as well. So that's why it's even more important that we have a higher profile for shock, because every worker on a work site can be shocked and electrocuted at low voltages, right? And it's low voltage that's the problem. If I had to make a statement about using the word dangerous, high voltage is not as dangerous as low voltage. And I can quantify that, and we can discuss that. So historically, and I talk about this all the time, in the US, the American Electrician's Handbook from 1942 to 1960 taught a worker that would do electrical work, let's call it a journeyman electrician or some task qualified worker, to use their bodies as voltage detectors, right? And so if you haven't ever seen it, when I first saw that, I thought someone wrote it as a joke, like it was a one page and it had it had the actual sections from the American Electrician. I said, someone's typed this up as a joke. I Googled it. I went online, and I actually own a copy. I own a copy of the 1953, and I just don't have it here with me right now, American Electrician's Handbook, and it was published, and we taught workers to use their fingers up to 250 volts AC. If you feel electricity, which means if you feel pain, the voltage is there, so you better stop and turn the power off. And then for bell and signal wiring, why don't we just put the wire in our mouth, and if we taste electricity, then voltage is present, and that's low voltage DC, and there's a reaction with our saliva, and you'll taste electricity. I haven't tried it, and I'm not going to stick a wire into my mouth, right? But this is the history of shock. We invented electricity hundreds of years ago, and the shocks were happening probably all the time, and people were dying. And and back then, forgive me, our societies evolved. So back then, workers were getting killed, users were getting killed. I'll use the word killed because there was no control. They were killed, right? And now we call it a fatality in the workplace. But why did it take until 1960 or 70 for occupational health and safety regulations to evolve? I don't know why, right? But it just did. So now that would have no longer been acceptable, and they stopped publishing it in 1960. So we've got this conditioned worker that's been conditioned that shocks are part of doing the job. And this is the history and the culture and the behavior of electricians. And sometimes this behavior is exasperated. It's not a behavior. It's just that's the way they were taught. This shock was not identified today in a company's occupational health and safety management system. So back when I was with Encana, I looked at our safety management system, and we had an exhaustive inventory of hazards. We had, like, our safety manual, if I probably printed out, would have been 10 stacked. And in our field level hazard assessment, we didn't have shock identified. We had language that said we needed to manage the condition of portable cord and plug connected electrical equipment, and we needed extension cords plugged into ground fault circuit interrupters, and we needed to manage our limits of approach to overhead power lines. But not one instance did the word shock show up. Okay. And that was it. So historically, shocks are happening, not reported, part of doing the job, taught to use our bodies as voltage detectors. That changes. OHSMS regulations come along. But today, the statistics are still there that shocks are occurring right now. Right now in the US, I guarantee you there is probably tens of thousands of electrical workers being shocked today.
Unreported too.
Right, and unreported because they're still not trained. They're not trained because their company doesn't have a policy defined in an electrical safety program that's been communicated to them that this is the electric shock hazard It's identified in the electrical safety program. In our electrical incident reporting section of our program, it explicitly in a giant bold letter says all shocks shall be reported no matter what voltage, all arcing faults, and all arc flashes shall be reported. So now if I have a policy and I train my workers on the policy, I increase their awareness now, and I also let them know that there's going to be, unfortunately, enforcement. So this is another challenge in electrical safety. PP's bought, send the workers on training, pay for expensive studies, put up labels that aren't compliant, don't manage it at all. Just trust everybody that I'm buying all this from as the employer, and then I haven't stated even the starting point. The starting point is policy, and the policy is let's turn it off. One, we need to identify when the hazards exist, and shock needs to be at the top of the pile. Now I'm going to make a statement that might be controversial, but it's the fact. There's no money in shock, right? The arc flash economy that's evolved is why arc flash is at the top of the pile.
Do you think because the PPE cost is minimal and it goes to shock protection?
And I all due respect for companies like yours, because you've brought something to the market, and Grace was one of the first companies. And I look back now, and I look back, and Grace brought out your products to industry before anybody else did, which is to eliminate exposure. Like that's the top hierarchy of risk control. So if we don't have to open up the cover, there's no exposed conductors and circuit parts, the shock hazard goes away. So the shock hazard needs a lot more attention. I'm going to mention something else that I identified a decade ago as well, is sequela, and I may be mispronouncing it, right?
Sequela.
Right? What was that, Bhanu? What was the pronunciation?
Sequela.
Sequela, right? So again, this is 10 years ago when I was getting educated. I can't remember how I found out, but the St. John's Rehab in Ontario, Canada, has an electrical injury program. And electricians in Ontario were reporting to their general practitioner that, they've got aches and pains and discomfort, memory loss, and, they're afraid to go to work, right? So by receiving multiple shocks, that journeyman electrician now has this sequela, and it's real, right? So recently, in the last year, and I know he won't mind me mention his name, but in Edmonton, Alberta, an electrician came forward to me. His name's John Knoll. He's on LinkedIn. If you want to follow him, I'm working with him to try and identify journeyman electricians and other task qualified workers and increase the profile. I want to potentially form some sort of group here to help electricians understand later, and this could be 10 years into their career, 15, 20, 30, 40 years, or you're retired right now and you're having all these effects that you think are old age. They're not necessarily old age. They're exasperated sequela from being shocked so many times in your career, and you need to get help, right? You're probably getting help, but your doctor may not know he's old age. Well, no, it's because you've been shocked. And the other challenge is PTSD, right? So again, this research in shock at St. John's Rehab was one of the electricians, and this is one that there's a doctor. His name was Dr. Joel Fish. He was the initial doctor that was involved in this. And there's a great video on YouTube if you look up St. John's Rehab. I think it's the invisible injury, right? Because it's invisible. And Dr. Joel Fish, he was a burn injury doctor. And somehow this arrived on his desk, and he felt that the electricians were malingering and this was just a way to get out of work. But when he researched it using his training, right, as a doctor, he said, this is true. This is fact-based. This is not fiction. These workers, these electrical workers have this shock hazard that they've been exposed to so many times that these longer-term effects like memory loss and fear. The one electrician said he couldn't remember how to drive to work. And because why? Because that's where the pain was, right? So shock needs a ton of more focus. We haven't dealt with it. We need to get these on every worker. Every worker needs these. And this should be the start of the kit for an apprentice electrician. Apprentice electricians, they're given a list of tools to go buy in the bookstore. They get their books, but they're told to go buy tools. This needs to be on the tool list. Class 0, rubber insulating gloves, 1,000 volts AC, 1,500 volts DC. An apprentice electrician should get these in school, start to use them in the labs, and then we create new habits, right? New habits that these will always go on. It's like when seatbelts became law, right? We resisted it, then there was enforcement, and now it's habit, right? So I think, when it comes to an electrical safety program, we need enforcement as well. So we need to have negative repercussions to the workers once you establish the policies, unfortunately, until their habits change. So there's a cultural behavior issue here with shock. There's this sequela that needs to be managed. And I'm going to be putting a lot of focus, I think, in the remainder of my efforts in electrical safety to change the focus to shock and low voltage shocks, electrical workers, task qualified workers, right? We need it to go away. And I just don't understand. Well, what I understand is it involves human beings, so that's why it's complicated. So we need to change the profile. Both hazards need to be dealt with, but right now we need to put more attention on shock. Shocks. Shock. Sorry, arc flash. Yes, because you'll have other people talk about arc flash and, well, Terry, if a worker's arc flashed and they have cotton or cotton poly blend clothing on, they're going to get a significant burn injury. Well, that's true, right? Let's identify that and deal with it. Well, the consequences of a arc flash are more severe than a shock. I don't think so, actually, because you're either going to get shocked and survive, or you're going to get shocked and electrocuted. There's really no in between, right? And then you can get some thermal entry and exit wounds from higher voltage shocks, utility workers, but the low voltage shock is invisible. We typically won't know that the workers received it because there'll be no thermal entry wound on the hands, because predominantly that's where the current's coming in the body, right? So this whole profile, we need shock to do like this, and we need arc flash to come down, and a level playing field. But ultimately, again, the electrical safety program is how the employer can take control of arc flash, get it under control, wrangle it in, right? And then get shock to come up and manage these hazards through that electrical safety program.
Cool. So I have a follow-up question, because we talked about electrical safety program, and whenever we talk about the electrical safety as a fundamental discussion point, it's always about compliance. So most companies use the safety program or safety practices just as a compliance measure, because there's a regulatory standpoint they need to comply to, correct? And what are some of the things from expert network program or electrical safety program, what we are offering from Grace, that will move the needle from the regulatory standpoint to more like a solutions-based approach? So do you want to elaborate on that? How we can change the mindset and thinking so that employers or facilities don't just look at this from the standpoint of compliance alone, so how they can make it more useful towards the day-to-day solution-based problem solving?
So I've shared my screen and I've put up this amazing flow chart that we developed.
You're sharing your screen. I'm not sure whether we can share.
I've shared it. So I've shared it on my end. Maybe you have to enable me on your end.
So Nick wants to share that screen probably. Yeah.
So I've shared screen. It tells me I'm sharing screen on my end.
Okay, good.
Got it? Can you see it?
I can't see it. But Nick probably, yes.
Okay, so up on the screen should be what's called the Electrical Safety Due Diligence Framework. So this is, again, a very cool, simple flow chart that tries to get this sorted out by the employer, right? So OHS regulations, and we're not going to dwell on that. I think there's enough information out there that it's clear that in the US, OSHA has language that says that these two hazards need to be identified and they need to be managed, right? Identified and risk controls applied to eliminate exposure, reduce risk. And it's this general duty clause. In Canada, we're regulated provincially and territorially or federally, and most industry is regulated at the provincial territorial level with OHS regulations, and the states as well, can have their own deviations from OSHA as well, but more predominantly in the states, the OSHA is it. But in Canada, the provinces do deviate independently, right? So that's at the top of this flow chart. So let's say we understand that, and this is where you need to start actually, but get beyond that right away, right? Don't dwell on it, because Terry, it's not 70 is not adopted into OSHA as law. Z462 is not adopted into any provincial, territorial, or federally OHS regulations of law. True, but it doesn't matter. If they're never adopted until at this point in time, it doesn't matter. the general duty clause in these regulations says all workplace hazards identified. So I'm just paraphrasing, summarizing, what to keep it simple, because you just don't want to complicate it. So OHS regulations, general duty clause, and then I got the hierarchy of risk controls on the right and hazard ID and risk assessment on the left.
Terry, do you mind trying to share the screen again, if you don't mind?
Oh, yeah, no, I'll do that. I went to the share screen piece. Hang on a minute. Okay, there, my mistake. Yep. Now we should be able to see the screen.
Okay.
All right.
Yep.
Okay. Sorry.
Yeah.
Sorry. So now this is the flow chart that I was talking about. Electrical safety due diligence framework. So I was talking about at the top, OHS regulations, general duty clause, hierarchy of risk control methods, hazard ID and risk assessment. And again, as an employer, you need to start there, because that's where this will all end up if you ever have to test your due diligence. And that's another topic, testing your due diligence. So all this activity that we've been talking about, bottom-up controls, so that has added some benefit, but it's not defendable and it's not sustainable or measurable by the employer. Getting organized through this type of framework, this on the screen, and ultimately in the middle, the core, the occupational health and safety management system, is where employers need to go. And if they're not there yet.
So one thing that reminds me, just looking at the slide, Terry, is we both stumbled upon that word, due diligence. Remember, while you're putting together the slides, like 2 months ago, we were just thinking about what is the right word to mention there, right? So that's due diligence. Do you want to expand on that, due diligence, why we arrived at the term due diligence when it comes to the framework?
Well, because when you look at, okay, forgive me, I said, we need to get beyond these regulations. Well, getting beyond them is understanding them. And then the two key words are due diligence. And due diligence, unfortunately, is subjective, right? So due diligence will be different for every employer to the OHS regulations. And just summarizing what due diligence is, it's how you decide what you're going to do and be able to defend with respect to those OHS regulations. So for arc flash and shock, well, you know what, NFPA 70E, I don't want to use that. We're going to just invent something. That's not good due diligence, right? And you could go that route, but if you ever have to test your due diligence, your company, meaning management and supervision, would probably be subjective to significant oversight, right? So due diligence is, summarizing in general terms, it's the decisions you make and what you do, and then how you can prove that they're working, the hierarchy of risk control methods with respect to managing arc flash and shock hazards. So you know the regs, you get to the general duty clause, you look at hazard ID and risk assessment and the hierarchy of risk control methods, and then you understand your due diligence should be writing some things down, right, in a safety management system, occupational health and safety management system. So standards are powerful tools, right? They're not management systems in this case, but they're tools, and they're toolboxes. And most of the standards are full toolboxes. The employer's due diligence is, how do I take the tools out of the box, and how do I get the tools into the field to achieve the goal, which is one, due diligence, but ultimately to eliminate exposure or reduce risk to these workers to arc flash and shock. But then it's being able to prove that due diligence, heaven forbid if there's ever an electrical incident. So ultimately, you drive down from the OHSMS to an electrical safety program, which is an occupational health and safety management system, but specific to arc flash and shock. And it needs to work with an employer's overall OHMS. And underneath it, we have a framework table of contents, and it says compliant to OHS standards 70E and Z462. So due diligence is subjective. It will be different in every company, and it is. Everywhere I've gone, every company I've worked with, it's not the same. But the core of what they have should be, because it should be based on starting with NFPA 70 or Z462. But unfortunately, I see divergence in how employers are interpreting 70 and Z462, again, due to, misinformation from non-compliant training, information in the engineer's studies that confuses them and sends them down different paths. Obviously, too much focus on arc flash and not enough on shock is one of them. So long-winded explanation, due diligence is subjective. Ultimately, it is what you do, right, to comply with the regulations, but it needs to be formal, detailed, comprehensive enough to a certain level, right? And then ultimately implemented, and then ultimately it needs to be audited. So along the path in the last 10 years, when I've worked with clients and they have something done, I said, have you audited it? The answer is no. I'm going, you didn't audit any of this? What?
It's done. It's done once for all. That's it. So then,
well,
it's a perfect system. So you don't need.
But it's not. So I want to load another graphic that we came up with. Well, we didn't come up with it. This is nothing new. The screen's moving here, right? And just give me a second to find it, right? Where is it? Oh, just again, screen's moving. Bear with me, please, as I find it. This graphic, right? Plan, do, check, act, right? So plan it, do, check, act. So this is then the next graphic from the flow chart, which get organized. How do I get organized? Well, this is a simple occupational health and safety philosophy from ANSI Z10, ISO 45001, CSA Z 45001, is plan it. So we talked about the regulatory piece. We hazard ID this thing. We write down purpose, principle, scope, objectives, targets. We benchmark, like I said earlier, I looked at my competitors, right? And then I said, well, what do we need to do? But I ultimately decided what we needed to do at my company at that time. And then I did it. I approached the safety department. I said, this is a hazard issue, 2 hazards. I need documentation. I learned quickly. And I don't know why industry has not learned that. I talked to people that are on this topic and they get back to, well, we bought PP, we sent the guys on training and I got studies, but ultimately, did you write anything down? Did you have a plan? What was your schedule? What was your end game? What was your deliverable of all of this? They haven't done that. And you do that by structuring a management system, right? So development, implementation, program, communication awareness, preventive and protective hierarchy of risk controls, competency and training. Competency is another topic we could talk about for a while. Incident reporting, emergency response, preparedness, procurement, contracting, management change, another topic, right, that needs more formality with respect to electrical power systems and arc flash and shock. But this information's out there. OSHA actually has a document, Bhanu, right? This is the craziness of this, right? There's documentation out there that supports all this. So basically, this is ANSI Z10, right? We've got Z535 with respect to the labeling as well. Like, there's so many useful standards out there that when I talk to companies, well, are you aware of these standards? Well, no, because these standards then give you the power to control, right? This is CSA adopted ISO 45001 in 2019. Actually, we also adopted ISO 31000 for hazard ID and risk assessment. This is another standard in Canada. This doesn't exist in US, but
Terry, I'm going to interrupt you here. Go ahead. Because these documents are great, right? So, but the question is, who has time in this world to go through all this documentation? That's the thing. Now, we see the facilities mostly on reactive mode, trying to firefighting the problems on a day in, day out basis. So nobody has got time. That's one of the reasons why we came up with this expert network services and your consulting ability, so that we can go and guide them and give them an organized procedure or policy and the program for the facilities to implement.
Well, maybe you're hitting on something you are hitting on something that's been the challenge. This is quite overwhelming. And that I was overwhelmed when I was at Encana, and it took me 2 years to sort it out. So, because I had nothing. Well, I had a very comprehensive, very detailed, very well implemented and audited occupational health and safety management system, but there was no electrical safety documentation. So you're right. It's overwhelming and everybody's busy, right? So you add this to the list of a safety professional that's dealing with 100 hazards already, and then you'll get this in the electrical engineering department of larger organizations or the electrical maintenance department. And forgive me, but electrical supervisors are very busy people. They already have a ton of administrative, responsibilities on their table, and then you try and load this up, and that's where it fails. Because it fails because maybe they well, if you read 70E and Z462, it says you need a program, and I think a lot of the training skips over those articles and clauses. But I think there's, Terry, well, yeah, I've heard about this electrical safety program, but I don't have time. You nailed it, because it's very easy to phone the PP vendor and get kits. It's very easy to send the guys on the training, and I can hire an engineer to do a study, but it's harder to write things down. So you're correct that there's a challenge here in the last decade, because some companies have tried to write some things down, but they never get it done because they're overwhelmed by the day-to-day, planned and reactive maintenance work. And usually It's the electrical maintenance department driving this, the safety professional, if it's a larger corporation's overwhelmed, especially, guess what, in the last 12 months, what else has taken over all of this? COVID-19, right? So then in the last 12 months, other workplace hazards, unfortunately, have been pushed down. Arc flash and shock have been, right? Because COVID overwhelmed everybody. Hey, that's an ongoing challenge. But now we need to assimilate COVID and get back to ensuring that arc flash and shock hazards, as other workplace hazards, are managed effectively. So you're right, time is a problem. So what I did is I tried to solve that problem for industry by saying, we can bring you a compliant electrical safety program, and then you don't have to spend the time, which costs you money as well. We via the Grace Technologies Network Electrical Safety Program, are now bringing this to industry to save them time, save them money, and move them to compliance quickly, right? Now, quickly means not overnight.
While solving their application problems, right? So
that's correct.
Correct. Yeah,
that's correct. Yeah. And then, here, and ironically, I just have, this other slide up. How long does it take to develop, right? So that's a simple Gantt chart. So but if you invest a small amount of time focused and get an electrical safety program, it will save you so much time going forward and money. And then back to that worker I said earlier, now with policies, practices, and procedural requirements written down, the worker can, this is my company's, oh, now I know how I'm applying the training, and now I'm going to get the value out of the training that I received. And I'm very thankful that my employer sent me on the training, or, geez, the trainer told me something different than this, right? And that's where, again, the employer takes control. They take control and can defend their due diligence, right? So wrapping this all under a wrapper, right? Back to that graph that I showed earlier, right? Just again, screen's moving, right? Is that we have this, right? And we're down here now at the bottom. We've developed this program that we started but never could get done because we never had the time. And now we have a solution, right? Remember, electrical safety program and solutions. Grace has solutions that are higher level, higher risk control methods already. And now Grace has added consulting and bringing a licensed electrical safety program to industry. And again, I know, and I've told you my story. We started out with my story that I had nothing written down. I looked at our safety management system and said, well, what does it say? And I told you that it didn't say anything. It didn't say arc flash and shock. It said, watch out when you're near power lines and use a GFCI, but never why. So companies need to start at the top. If they have a safety management system, I know right now, it will not have arc flash and shock in it. It'll have no electrical safety content. 70E and Z462 mandatorily require an electrical safety program, but 70E and Z462 are not electrical safety programs. Well, Terry, we just take 70E and we've got Z462 and we have it in the shop, and we went on the training and we look up and hear what we need to do. That's not a management system. That's applying a standard incorrectly. It's a toolbox, and companies need to take control by having a compliant electrical safety program where they define their company's policies, practices, and procedural requirements. So, Bhanu, it's again, yeah, time can be saved and money can be saved. The opportunities there if employers are looking for how to move through this to get to the other side.
So let me take a step back and ask you one thing. So we talked about electrical safety program and what the benefits of this, bringing in alignment between the health and safety management systems and electrical safety. So what is the first step when you define the electrical safety program that needs to be considered? And then who is that responsible person at a facility level to take control of this electrical safety program development and implementation?
Okay, so I mentioned earlier that where this has historically been driven from is the electrical maintenance department or the electrical engineering department, but those are larger commercial industrial employers. The challenge is the smaller employers, which is where there's tens of thousands, hundreds of thousands of them, small electrical contracting companies, smaller electrical maintenance and testing contractors, large construction companies, and then the end users, right? So usually it shows up at the electrical maintenance department. And, with the supervisors, become aware the strange thing is the IEEE Electrical Safety Workshop, it's a lot of electrical engineers, a lot of electrical engineering technologists, not that many safety professionals. So there's the other problem. A lot of this is being driven by the electrical engineering community, which is a challenge. So after that happens, it's like I said already, that if it's in the maintenance department, the supervisor's stuck, right? Because they're overwhelmed. And there's another challenge with supervisors in general, not only with respect to electrical workers, but other trades, is the bureaucracy, the paperwork that they have to manage is debilitating them from being really supervisors. And again, I'm just generalizing a statement. This won't be the case for all supervisors, but even supervisors that want to be more involved with their workers are stuck. And that's an unfortunate evolution of business. So it'll get stuck. It'll get stuck on the supervisor's desk. Well, I need to write some stuff down, but I just don't have time. And then it's sitting there. It's literally sitting there like that to write something down. Or they might write a page down. And then it'll take, and 2 years later, they've got 10 pages, right? So, and the safety professionals, they speak this language, right? So they know the language. They know if there's a safety professional listening right now, they'll go, this is right up my alley. I get what Terry and Ben are talking about. But they're overwhelmed because there's 100 workplace hazards. In the last 12 months, they've been dealing with one at the top of the pile, and they don't have the subject matter expertise. So there is some electrical knowledge that's required here, unique to these hazards. The hazards are present on electrical equipment that's energized, and safety professionals don't know anything about that. They have no experience, and they have not received any training. So a decade ago, I tried to influence safety professionals, and I got overwhelmed by it because there was just too many people to deal with. I went to occupational health and safety conferences to get the word out to them, and I tried to present at these conferences, and it was too big for me to handle. In Canada, there's what's called the Canadian Registered Safety Professional Designation, CRSP. So there's curriculum developed by a national association for safety professionals. And then this is how someone has some background training, could be a trade, could be a university degree, you name it, or some sort of profession. They take that training curriculum and they become a safety professional. That curriculum still does not have arc flash and shock content on it. So just to summarize, this is being driven by the electrical maintenance supervisor who's too busy, right? Overwhelmed, tied up doing paperwork, not spending enough time with the electricians day to day in the field, mentoring them, coaching them, right? In the field, right? And then obviously stewarding, getting some other senior electricians as foremen or lead hands to work with the less, the more junior electricians. And that's sort of standard, maintenance department, organization. They're stuck. The electrical engineer gets focused on the studies, right? And doesn't realize what this program is because they're technical people, right? And then, like I said, the safety professional is so overwhelmed, and here we are talking about it today, that electrical safety programs, they don't exist in many organizations. If they do, they're not compliant. And I use that strong word, compliant, because I've reviewed them, right? So long-winded answer, Bhanu, but if you haven't, anybody that's listening right now, Terry has a lot of background, a lot of experience in 13 years dealing with this directly for the employer he worked with initially, and then across Canada and in the US, right? Trying to help employers, individuals, whether it's a safety professional, an electrical engineer, a supervisor, or electrical workers or task qualified workers to get this right. And I use that, get this right. We need to get it right. Right now, we're not getting it right. Industry is not there. And if they understand this, and hopefully this is helping today, this live stream, and it's going to be recorded so people can view it offline, that, Bhanu, you and I right now are increasing the profile. I think, and ironically, here I am 10 years later, Bhanu, and I have to thank you and Grace for this opportunity to allow me to have the profile that you're allowing me to have, because there's a lot of voices out there, a lot of voices.
And then there's all these things are being implemented in bits and pieces manner, but there is no other.
Right. So the challenge is the other voices, right, that are out there, right? So when I say voices, there's a lot of influential people in electrical safety in the US, and their voice is louder than my little voice. And, that's okay. And they'll have certain opinions, and, they're influencing industry, right? And again, guess what the influence is? What have we been talking about mostly today? And what have I said is the current problem? They're influencing Art Flash.
Okay. So I would like to take the next 45 minutes or so, Terry, to go through about two things. One is, okay, if you have a facility and if you don't have a structured electrical safety program, and if you're interested in one, so what is the first thing to do? I think Nick told that he's going to put that survey that the viewers can take as
The
part
electrical safety self-assessment, right?
So with which they can just gauge themselves or the scoring method for them to know where they stand from the maturity side of the things. And then if we want to start this electrical safety program, what is the first step to take? Can you just brief this process, how this works, how this electrical safety program works, and then how we can help the facilities to get into a compliant program?
So occupational health and safety and the standards that relate to them, Plan, Do, Check, Act. So let's start with the check piece, right? The check piece of the Plan, Do, Check, Act philosophy. So remember the Plan, Do, Check, Act philosophy that I just had up on the screen previously. Mm-hmm. And here is a simple tool to help you get organized, right? To do a simple gap analysis by using a document like this. It's an electrical safety program development and implementation checklist. The electrical safety self-assessment has 20 questions. 20 questions is not enough to help you understand where you are and where you need to go. It's a continuous improvement model. And when I talk about gap analysis and the stronger word audit, people react. You're going to audit us? And there's fear involved with that word because it's...
I mean, we should change that word from audit to self-reflection. Maybe a right word to use.
Self-reflection. Softer words, because then maybe industry and people that in companies wouldn't be, afraid when they hear the word audit, because what they're afraid of is that they've done something wrong.
Yeah.
And that's not the way that this should be presented. Audit is an opportunity to improve, right? So again, when you say audit within your company, explain to people and use the Plan, Do, Check, Act philosophy, that flow chart, right? And again, that we can gladly, this information's out there, but that flow chart is where you need to start. And like I said, it's embedded in ANSI Z10, ISO 45001, or CSA Z462 45001. So let's start with the check. Well, Terry, we need a plan. Well, our plan is let's start with the check, right? So let's figure out what we've done and what we haven't done. So the electrical safety self-assessment, and I think, Bhanu, the plan is to change up the questions, right? So that you can go online and do a self-assessment on Grace's website, right? So those questions were extracted from this complete development implementation checklist, right? So I just said, do you have a documented electrical safety program with framework, table of contents consistent with the requirements of occupational health and safety management system standards such as ANSI Z10, ISO 45001, or OSHA's recommended practices for safety and health programs, or VPP, voluntary protection program, right? So this is like 6 pages, 9 pages actually, sorry, 9 pages, Terry. Why is there so much information? Bhanu, I always get asked that. Terry, why is there so much information? Because this is a detailed, comprehensive topic. You can't solve it in a page. So you need the right amount of content in any of the documentation. 70E and Z462 are detailed, comprehensive, prescriptive standards for workplace electrical safety that stipulate the need for policies, practices, and procedural requirements. So that's why there's a lot of questions here, right? These questions need to be answered. And again, there's no scoring. So if you wanted to get a little more sophisticated, we could weight these questions, right? We could weight these questions. And on the self-assessment, we did weight the questions. So in the self-assessment that you can perform on Grace's website, we weighted the questions because you can weight the questions. What I mean by that is, what's more important? Is it more important to have a lockout tagout program, right, as well? So as your electrical safety program, that would get a lot more weighting, right? So do a self-assessment, do a gap analysis, do an audit. We can share this development implementation checklist if people request it or want it. All they got to do is get in touch with Grace, and we can send you this document. Because, Terry, how did you get those questions? I sat down and I spent some time. And over years, I've added to these questions. That's why there's 9 pages.
So just a quick point here is basically, It is not a rocket science. This safety program is basically organized and a structure for you to just go through all these different little steps without going through the mounds of information as defined in several standards. So basically what Terry has done is bringing in all those things in a cohesive document where you can go through in a very logical way and the systemic approach without going through 340 pages of documents. Is that a...
Great. That's right. Something else, Bhanu, that a sneak peek is get organized again. Well, what I talk about too is do a more formal gap analysis. That's a development implementation checklist, this document, right? So this is a development implementation checklist, right? But target your review with an arc flash and shock PP inventory document and an energized electrical work task inventory document. So no matter where you are along the timeline of your evolution through electrical safety, stop, audit, gap analysis, right? And use documents to do it. So what do you mean, Terry, about arc flash and shock PP? If you've got a large organization with enterprise-wide, divisions, you'll get divergence on this topic. I'm dealing with some clients right now where there's divergence. They're huge companies, and they let their business units go off and do things independently. So you want to find out what arc flash and shock PP is currently in the field, right? So get organized. You're in the check piece. So there's this development checklist, check the PP, and inventory the work tasks. All right, inventory the work tasks. Why do we want to inventory the work tasks? Because 70E and Z462 are job and discrete work task-based standards. And they talk about executing the jobs, which means I do one thing, like do a voltage measurement as a work task or multiple work tasks. So you want to get a list of what work tasks are performed on your work sites. And if you're enterprise-wide, you want to send that to 4 different facilities because the list is probably different. And through the electrical safety program, you want convergence and consistency, which is another word with respect to due diligence. Divergence across a company is risky because you could get caught, right? So in safety, you want consistency, and you do that through a corporate safety management system and a corporate electrical safety program. So this is a task table, Bhanu, and it's based on the task tables that are embedded in NFPA 70E, right? So, but take the standard and grow the standard, right?
So yeah, I wanna just throw this on the screen if you don't mind. Just see here if this shows up. I'm trying to share something.
Okay, you can take the screen. Do I need to stop sharing?
Yeah, please. 1 second.
Okay, I've stopped sharing.
Do you see this is what you're talking about, right, Terry?
Well, the back to the framework of the program. So that pyramid is the framework, but what you've got beside it is what I'm talking about is workflow.
Correct.
So energize electrical job workflow. So I said earlier when we started this that one of the things that this is about is we give work to workers. They don't show up and walk around and just randomly decide what to do.
Correct.
That's not good business. It's not productive. So an electrician in a maintenance department is assigned planned work or could be doing reactive. So ultimately the program, the electrical safety program, services that workflow. And again, that gets us back to understanding what our current workflow is, but what are our current controls? Thus, the gap analysis for what arc flash and shock PP is currently available and what energized work tasks are performed in our facility, our workplace. And then ultimately that information's above this, right? And then we define, well, what's our workflow? And then the workflow has to be twofold. What does the occupational health and safety management system require us to do with respect to hazard ID, right? And applying controls, because that might be a field level hazard assessment document or a pre-job or a start card. There's all sorts of different names for these. In fact, this is one of them. This is actually a field level hazard assessment as an example, right? It's all hazards on here, and then it's padded, and then you rip it off. And on the back, right, on the back is where the worker writes down their task steps, they write down the hazards, and then their controls. But this is a generic field level hazard assessment in the workflow. The problem is right now, this one, it's dated. It's from the Alberta Construction Safety Association. And under electrical hazards, it says GFI test, lighting levels too low, working on or near energized equipment, electrical cords condition, electrical tools condition, fire extinguishers under electrical hazards, hot work or electrical permit required. So this is historical. A safety professional would have done, but those aren't electrical hazards. A lot of those are controls. A fire extinguisher is, unfortunately, hopefully you never have to use one in an electrical room because you've had an arc flash or you've had an arcing fault and a fire, right? So this is back to the history. So Plan, Do, Check, Act, do any form of gap analysis, the development checklist, send out an inventory document, find out what arc flash and shock PP is there, find out what energized work tasks are performed, and under your existing safety management system, what hazard ID tools are out there, task analysis, job hazard analysis. There's all sorts of different language doing the same things. And ultimately, though, stop and do a gap analysis. And again, we can help you do that. We've got that development checklist. Our self-assessment on Grace's website is just a simple tool to gauge, some level of performance with a score. But if you want to spend more time,
it's no cost. Anybody can go and take that and just push a button.
Yes, but if the development implementation checklist is something that if someone's interested in doing a more comprehensive gap analysis, let's do that. I just also want to talk about something else. This is very interesting. It's a caution card. It's another hazard alert system. This is for near miss, near hits, right? So that's another overall safety management system document. So if you were potentially going to be shocked, that is a near hit, near miss report. So there's other documents here that can be put into place if employers don't have them. And then ultimately, what we need to have happen is we need, right, documentation in place that's electrical hazard specific, job safety planning forms.
Hey, Terry, quickly, you mentioned the documentation several times throughout this live stream. Can you elaborate why documentation is very important? I think most people don't understand the criticality of the documentation. Can you just explain that in a bit, please?
Well,
in a manner, if you
remember, I'm an electrical engineer, so I was trained to think about many things from different perspectives. And this is another challenge with electricians. Guess what they're trained to do? They're trained to use tools like this, right, to solve problems. And they're really good at it, but they're not good at writing things down. And this is a critical statement, but it's fact-based. Every time I ask an electrician to write an electrical safe work procedure and give them a blank piece of paper, maybe anyone listening wouldn't be surprised. They struggle, right? So they're tools workers. They grab things, they grab these probes and leads, and they go solve problems, right? And we need them to do that, and we need to be confident in doing that, like I said. But the lack of documentation, it could be a laundry list of things. There's no guidepost, there's no rules, there's nothing. It's a blank piece of paper. If I give a blank piece of paper to someone and tell them to go do energized work based on the training, and here's your HRC 2 or 4 kit, and we got labels on electrical equipment, what are we going to get out the other end, right? Where we're going to get out the other end is a confused worker, right, that I'm just grabbing something quick, that sees these on electrical equipment, and it fails, Bhanu. Without the documentation, this has failed over and over again because the electrician won't be incented to apply the training. The investment is lost. They don't get the residual risk achieved from the training. And there's no evidence. There's nothing to gauge performance against. There's no measure. There's no KPI, right? So energized electrical work permits, that topic hasn't come up yet. Yep. And that's another one about documentation. So it relates to your question. So now let's talk about that, right? I got a copy of 70E way back when, right? And I'd read about the permit, and the permit hasn't really changed much between that and this, right? So, but it's been totally misinterpreted in industry. I started working for a client in Ontario, and they said, Terry, we're issuing permits for every job. I said, what? I said, yeah, it's getting real bureaucratic, right? We got to get signatures. And then every electrician now wants an energized electrical work permit, or they're not going to work energized because they feel that if they don't have the permit, they're going to lose their job because they heard that it's against the law to work energized. So if you have an electrical safety program as the employer, you can take care of that whole laundry list of problems that I just identified. You'll know when the energized electrical work permit's required and when it's exempted. The workers will understand that they don't need an energized electrical work permit legally to work energized. The fact that they have a journeyman electrician ticket in their pocket is their legal authorization to work energized for an employer. The employer authorizes them to work energized, and we can document that in the electrical safety program. So ultimately, the worker has confidence, clarity, and they go do energized work, and their residual risk to them will be as low as reasonably practical, because the likelihood of occurrence of them making an error because they lack confidence, they believe they might lose their job, goes away, right? So right there, the electrical safety program will get the journeyman electrician or their test qualified worker beyond all the myths and misinformation over the last decade, and they'll have confidence, clarity, and their likelihood of making a mistake will be as low as reasonably practical. Their human performance, which we could talk about for an hour as well, right, will be the best that we can make it. And ultimately, human performance is a relationship between the supervisor and the worker as well, right? So
since you're talking about energized electrical work permits, right? So is it common, or do you see this happening in the industry itself? Like people do this irrespective of putting a permit in place just because it's too bureaucratic to go and get the signature. Someone would just open the cabinet, get the work done, and move on. Do you see that happening in the industry, Terry?
Totally, Bhanu. But yes, so basically, the permit's being used for the completely the wrong reasons. And in my opinion, if the company understands 70 and Z462, which right now I'm saying industry doesn't, they will add additional exemptions to the energized work permit in their electrical safety program, because the permit's a permission document. So the permit, we talked about these bottom-up controls. If anything's been grabbed out of 70E, it's the permit. And then I'm going, well, where's all the policies and practices before that, right? Well, we're using the permit, and it's got these three parts, and we fill out the top part, then we document, the middle part, and then we get signatures, and we need the CEO's signature. I'm going, the CEO, right? You've totally missed what this permit's all about. It needs to be operational. If it's used, it should be at that level. Someone requests energized repair and alteration. The justification is valid. We document that. We fill out part 2, which is really, identifying the arc flash and shock hazards and writing down some controls that we're going to apply. But that should actually be fulfilled by a separate electrical job safety planning form. And then we get signatures. The signature should be the electrician or electricians if it's high voltage, then the supervisor, and one more signature after that, the manager of the supervisor. That permit should be operational. It should never see a VP's desk, right? Because it doesn't make any sense.
Correct.
Right? So, and I'll see multiple derivations. Like I said, the other example is every electrician was given a permit because the electricians felt if they didn't have the permit in their pocket and they were caught doing energized work, they'd be fired. And again, so this is, again, the myths and misinformation, no documentation, or documentation that's maybe incorrect, right? Because you've been incented by a trainer or someone else that we need a permit for every job. It takes a company down a rabbit hole. Another phrase I use, we're in these rabbit holes, and we're digging these rabbit holes deeper and deeper, so that as we continue to proliferate our use of electrical energy for the benefit of humankind, right? And remember I said globally, like we haven't even touched on this, Bhanu. There's workers doing electrical work across the planet, and we would probably just go, wow, right? And so, but here, really, our focus is North America, but my focus is global as well. Like I said, I actually presented in India once, Bhanu, at an IEEE event, and I talked about auditing, believe it or not, in India, about auditing, right? So, which was over the top. When I was there, that topic overwhelmed everybody, by the way, when I did that presentation in Pune, right? That was 5 or 6 or 7 years ago. But nonetheless, the permit, this live stream, they're talking a lot of stuff here, Bhanu, but I'm telling you right now that if people understand it, getting a compliant electrical safety program solves every one of the problems we've been talking about. Every one of them is controlled. They go away because
you have a structured program that encompasses all the elements what we talked about since we started this presentation, right? So before I lose this thought, so is this safety program just aimed at qualified electrical workers, or is it taking into consideration task qualified, non-qualified, and qualified instrumentation workers, engineers, and all types of personnel? Do you want to just explain on that, Terry?
So if companies do have electrical safety programs, you'll find that they just concentrate on the journeyman electrician. They don't make it an all-worker program. So the Grace Expert Network Electrical Safety Program is an all-worker program. And I said earlier that non-electrical workers using portable cord and plug connected electrical equipment, guess who needs some awareness training, which can be handled very effectively at the work site. You don't need to send these workers on focused arc flash and shock training. Totally the wrong solution. You can have the topic covered in a safety meeting or a meeting of the month, or information bulletins issued and then put on bulletin boards. So a compliant electrical safety program includes all worker roles, and it starts with management, then supervision, safety, engineering, qualified electrical workers, and then low and high voltage. What? There's two different qualified electrical workers, Terry, and then a task qualified worker, which would be an HVAC tech, a cathodic protection tech, elevator mechanic, overhead crane.
Do you want to share the screen, Terry? What you have already have is defined, because you have on the main document you have those definitions.
Okay, I'll where was that again to share the screen? There we go. All these web-based softwares are all different.
No, we got to
they're different. Okay, so what I'm going to do is I'm going to go over to the actual electrical safety program. This is a compliant program, and I'm talking about all these roles right here, Bhanu, right? So see all this, right? You're going, Terry, that's a lot of information, but that's, if you start with a program and say, okay, we start with this, Terry, we don't have those worker roles, then you take them out of the roles and responsibilities section, but you need all these other workers again. And
the screen, do you want to?
Oh, sorry, I'm sharing the screen right now.
Share, and then you got to select the screen, I guess.
I did. I'll try it again, right? So share screen, share. It should be there now.
It's not there yet, so.
It tells me it's sharing.
Now it is. Yeah, now it is.
Okay. All right. So now what I showed this electrical safety program, right? And this is a compliant electrical safety program. You can see we're leveraging on the title page the hierarchy of risk controls, save lives, ensure confidence and consistency across your enterprise. That message has been clear in this streaming event that you and I, Bhanu, and so basically what I have a table of contents and I was showing the roles, right? So a compliant program addresses all worker roles, and if you don't have those worker roles at your workplace, then you delete them from section 3. But we're all the way down to the non-electrical worker, qualified operations worker. Now that's another one too. Terry, what do you mean? Well, in industry, whether it's manufacturing, oil and gas, forestry, you name it, there's a plant operator. A building operator for a high-rise, a 100-story high-rise in New York City, it has an HVAC system that's unbelievable, right, to keep that building warm or cold, and has building operators. Operators operate energized electrical equipment. They're the front line. So they actually do some initial troubleshooting when the power is turned off to branch circuits. The motor's not running. These are trained, qualified workers. Depending on the company, they may allow them to do resets. What do you mean they're doing resets? Overcurrent resets? Overloads? Relays? Well, you tell me. And then we'll write it down and control what they do going forward. So through these roles and responsibilities descriptions, we establish policies for these workers, what they can and can't do. Now, we didn't talk about what energized electrical work is yet, but that's another topic. So working on is diagnostics and troubleshooting or repair or alteration, but there's 2 additional classifications. Operating, which is not maintenance and not energized electrical work and not working on, and isolation work tasks. So this operator does isolation work tasks. What do you mean, Terry? They can't do that? No, they do, and they shall, and we need them to isolate low voltage electrical equipment branch circuits. They turn off the motor that services the load, and then they do isolations. How do they do it? Well, Terry, we can't let them open the circuit breaker. No, we do. They are. There's hundreds of thousands of building operators and plant operators doing low voltage isolations. But that's a non-electrical worker, and we need them to be aware of arc flash and shock hazards. And an operations worker should never be exposed to arc flash. A non-electrical worker should never be exposed to arc flash as doing their job duties. So this gets back to HR departments, and when we hire someone, we have a role description, right? So there's an overlap with hiring practices because it'll state qualifications. You have German electrician certification, and we need to see your certificate, right? But non-electrical workers are a very important role. Again, portable cord and plug connected electrical equipment. GFCIs. I've seen too many extension cords wrapped with electrician's tape. When I go on a client site and I'm doing an external electrical safety audit, I go into the shops, the welding shop, the woodwork shop, the millwright shop. I go into all the shops, and I tell you, welders, they're abusers of portable cord and plug connected electrical equipment, but they got boxes of electrician's tape, right? So again, if you ever see a cord with electrician's tape on it, bag it and tag it. It's no longer approved in anywhere on the planet, right? So it's again, that's managing risk. So the program, again, purpose, principles, and scope, and then applicable acts, codes, and regulations, right? Roles and responsibilities, and then the framework or the table of contents needs to address 70E OHSMS standards, so safe installations, electrical equipment maintenance, electrical hazard ID and risk assessment, policies, practice, and procedural requirements, arc flash and shock PPE, training, incident management, incident reporting, emergency response, contractor management, whole other topic, audit, management change, and management documentation, right? So Bhanu, it's that what you saw? Industry doesn't have that. I prove it over and over again.
So is it reasonable to say that this safety program is all-encompassing, and then it is up to the facilities to go and look at what really applies to them and then be able to put that around their programs and facilities?
Because we come back to the plan piece, right? So we come back to the plan, right? So I said check. Once you check, go back to the plan, right? So again, okay, now we've done some check. We know where we're at. We've got status. So then now we go back and we customize this electrical safety program, right, based on our company, what work tasks we perform, what worker roles we have working at our work site or work sites across an enterprise. So the other thing too is it's project management based too. So I'm going to share the screen again because this is something else that project management is a powerful tool, right? So let's use project management and project management tools and practices and principles to sort this out, to get organized and formalize it. So, okay, Terry, what do we do? Stop, do a gap analysis. But before you do that, define that we're going to have a project. We're going to have a project to review where we are in our company with arc flash and shock. So we're going to do some quick check gap analysis stuff. But our plan is, right, phase 1, phase 2, phase 3. And this is the planned approach with project.
The document, Terry, or are you trying to share the document?
Oh.
No.
So I'm not sharing again? My bad.
Every time it just goes into
doing that again. I thought I was sharing. So no, again, I was. Yeah, I'll share again. So sorry. I always do that when I'm online presentations.
No.
Okay, so
Yeah.
can you see? Yeah, you can see. So what I was doing is I was sharing this
Correct. Yep.
project management placed approach. So I said, get organized, right? Do that gap analysis, but define a project. So write it down. Write it down. That's the problem. No one's writing anything down. Write down the plan.
Everything is here, Terry.
Sorry?
Everything is here.
So you can see this? Can you see this? The project plan?
You can see the screen, yeah.
Yeah. So phase 1, define what you're going to do, outline a schedule, electrical safety committee. So a lot of companies, it's like one person's doing all this. No. Get an electrical safety committee. Get management sponsorship. This all makes it credible, defendable, and allows you to get budget, to get money. Money to just get people together to talk about it within your organization. So get an electrical safety committee together, management commitment, get that time budgeted because it's money, schedule meetings, and then do the gap analysis, and then review documentation, customize it, prepare the final program, get management approval, follow a management change requirement. And there's actually a management change form that's part of the program. And then you want to roll out the program. Well, Terry, what about all that generic arc flash and shock training? Well, we still want to do that, but we want to train our workers on our electrical safety program. Now they're going to know what they can do, what they can't do. They'll know the policies, practice, and procedural requirements. They'll know how to apply the training to get the value out of the training. They'll become electrically safety competent by applying the training, by applying your program. And then phase 4 is maintenance and audit. So 1 year after you develop a program, audit it internally, external electrical safety audits. Not many, Bhanu, I said earlier, companies are not even doing internal audits or external audits. And I'm telling you, an external electrical safety audit is an amazing opportunity again to bring someone in that has the blinders off, right? That'll help you look for opportunities, right? So all of this is it's not.
So you mentioned about competent electrical worker, right? So sitting in a day and a half worth of electrical safety training, does it not make one competent?
Oh, no, okay. Well, you brought it up. I said it earlier, but you brought it up. All right. So let's talk about competency, right? So I've put this up, right? So human performance. This is related to the competency topic. It's another element of it, but I just because I had it available. So Terry says he's qualified. Well, that's great. And then he self-assesses his competency. So I said, Bhanu, you hired me. I worked at so-and-so company. I did low and high voltage work. I know it all. I can do it all. And you're my supervisor. And you go, hey, great, you're hired. Right? But did you validate any of what I just told you at all? Did you phone any references as a starting point?
You showed me a certificate that you sat on a safety training, Terry.
What's that, Bhanu? Yeah, well, no, I got a certificate. So I showed you my certificate. And arc flash and shock training. Well, first of all, I gave you my journeyman's ticket that I went to school, right? But I didn't tell you that I only did residential wiring for the last 20 years. And you never asked, right? So again, the supervisor and the worker establish a relationship of qualifications being identified, but then competency is what have you actually done with that qualification training, and did you do it correctly? So training is knowledge transfer. Competency is using the knowledge correctly to the benefit of what the training was trying to achieve. So electrical safety competency. You can come up with a competency checklist as well. I've done this for clients as well. I've gone through detailed electrical safety competency validation. And then when you get into competency, you apply audit tools by interviewing a worker, observing them, or testing them. What do you mean test the electrician? Well, test them. You're the supervisor. It's within your responsibility to deem them competent. So competency is validated by using those validation and verification techniques. And guess what? To my knowledge, this is another gap in industry. No one's validating electrical safety competency. This is not the audit is the management system. This is the individual worker, but we audit the individual worker. Terry, that's a word, audit. The workers get defensive. Everybody's competent. What do you mean everybody's competent? Who validated it? Well, trust me, everybody's competent. So this is another, and there's some politics involved in this topic, which we're not going to get into in this live streaming thing with respect to competency. But qualification training, I'm a journeyman electrician. Here's my ticket. I was sent on arc flash and shock training. I've got that certificate. So I can do energized electrical work, no problems whatsoever. I know exactly what to do. Just don't worry about it. And Bhanu, you're my supervisor. Okay, go for it. Did you come out and observe me, Bhanu? Well, no, you were too busy doing paperwork, right? You trusted me. And so, yeah, I want you to trust me, Bhanu, but competency validation and a supervisor managing their personal liability with respect to OHSMS regulations, it's not a matter of trust. It's a matter of being a supervisor, observing the worker, helping them, mentoring them, coaching them, and then testing them, right? Get them to, what do you mean test? Give them a 10-question test. That's self-assessment we have, Bhanu. Give that to an electrician that says that they know all about arc flash and shock, and they're fine. They're low risk. So you could test them, and then ultimately you interview the worker, right? So interviewing, which means you're asking them questions directly. Like a test is self-directed. I answer all but when you're interviewing, it's more face and interaction. I've done external electrical safety audits where I interview, and in that case, I'm not checking competency on the worker. I'm checking that the employer has given them all the things they need and that they understand them. So here's a quick competency check on electrical safety. What's the approved mark on an insulated hand tool, right? And every time I ask that question, it'll have CSA on it or some UL thing or something, right? And I'm telling you, I get the wrong answer 80% of the time.
And rating. It has a rating, like category 3 or category 4.
No, but that's this test instrument. Right? So as an example, this test instrument has a category rating on it. That's not the insulation rating, right? So again, these, right, are insulated, right? These are insulated, right? So insulated to what? Well, to a certain level of voltage where I'm not going to get shocked when I use these, because the insulation won't allow right? The current at a certain voltage to flow through that insulator. But this is an electrical safety competency check, and I rarely get the right answer, which is American Society of Testing Materials F1505, right? Double triangle voltage. That's the approved mark for North America, because in Canada, we don't have a CSA standard for insulated hand tools, right? This is screwdrivers and pliers. And by the way, you can get any insulated hand tool in North America. And some manufacturers, one of them that's a really good company in Pennsylvania, right, will take a hand tool and insulate it, because the ASTM F1505 standard allows them to do that. And by the way, the insulation doesn't have to be orange. It can be different colors. So when you see an insulated screwdriver, it's orange with a layer yellow underneath, but the mark has to be double triangle. So that's an electrical safety competency check question. And it should be, of 20 questions, if I was a supervisor, that I would put on the list that I could do, once every 3 years before I retrain everybody, as I do a check of the status of electrical safety competency. One of the things that I've tried over the years is pre and post testing, right? Pre-testing establishes the electrical safety competency of the student before they do the training, and then post, and that's the problem with training: 4 hours, 8 hours, 20. The knowledge that you're transferring is overwhelming. So a knowledge test at the end, post, doesn't mean competency. The pre-test tells me if there's electrical safety competency. So again, this is Terry, oh my God, this is, wow, Terry, you're talking here for hours about all this stuff, and I'm overwhelmed.
We got 14 more minutes, Terry, before we conclude this. So I want you to explain a little bit more, about what is provided as a program. I'm going to share a few slides about what we can offer with this program at different levels and different types of the facilities. I'm going to share the slide, and I want you to just quickly give like a 10 minutes briefing on what it is and what we do.
Yeah, so let's go through that.
Do you see the screen now, or I'm not seeing?
Nope, I don't see it yet. There we go.
There you go.
So where we're going with this is, and I need to thank Bhanu personally, right? His personal commitment to electrical safety is blown me away here in the last 10 months that I've been working with him as an individual, as an electrical safety professional, right, and working for his employer. He, again, and Bhanu has mentioned, we've known each other for a long time, but we really didn't get together until last year after the electrical safety workshop in Reno. So I want to give him a lot of credit here, credit due for himself, his contribution to this topic of these two hazards for industry, wherever Grace is. So let's start there. And now he said, Terry, you've got background, I think great Bhanu and Grace recognized my passion, but he also knew that I had this program. He was aware of it. So I said, let's partner, and you already had a plan and a strategy to expand Grace's offering for its clients, which is good business. And that's good business for your company. It's good business for your clients. And so now what's resulted is this electrical safety program, Grace Technologies Expert Network, and it's just the beginning, right? So basically, it's a complete program. It's licensed. It's templated documentation, if we call it that. It's compliant to everything we've been talking about all morning. It's complete. You don't start with a blank piece of paper, right, where I said everybody usually starts. You start with something that we're telling you is compliant, and then you need to review it, right? You need to then strike an electrical safety committee, develop a project, and have that committee review this, customize it for your organization, right? So it's complete main document, appendices, forms, and flowcharts. And the other thing that I see when I arrive is companies have electrical safety programs, but it's just that. It's a main document. And they might have the energized electrical work permit broken out as a form, but they have no supporting materials to help this qualified electrical worker become electrical safety competent, to bridge the training, the knowledge transfer that was 2 years ago, or 1 year ago, or 1 month ago. So there needs to be other documentation here. And I call it field-based documentation, right? So they're tools for the worker. So the main program meets the employer's requirements for due diligence with supporting appendices, forms, and flowcharts and infographics. And all of this forms the management system, right? So, the other element we didn't talk about risk assessment yet. No. So the other element of this is there's a risk assessment built into this program because it needs to be there. Why does it need to be there? Because in this document, right, it says you need a risk assessment procedure and it needs to be part of the electrical safety program, right? So that's also something that's in here is Article 110.5, and I've opened up the toolbox, right? I've opened up the toolbox and I'm looking at the toolbox again, making my plan. It says I need this program. I got these other standards, risk assessment procedure. We're providing you a risk assessment procedure that you validate and then you apply. There's an electrical hazard risk assessment matrix in here. There's a risk register table in here, and we've completed that for you. But again, you have to validate it. It's work task based. It's qualitative. So everything's in here that's missing, Bhanu, in existing programs that companies will have. They can get this program. They can adopt this program. They can use this program to update their existing program. 10 to 1, what they'll do is they'll realize that this is compliant and complete. They'll take the customization, if they have an existing program, and move it into this documentation, right?
So I'll just go to the next slide and show exactly what different levels and stuff, what we do with this, right? So,
yeah.
This is basically, do you see the screen, Terry?
Yeah.
Okay. So
yeah, so we talked about this, and again, there's inherent value here, right? So I tell companies, well, if you've been doing this, how many hours have you spent on it so far? Well, over the last 3 years, I've probably spent 300 hours, right? So, we take the 300 hours down to 0 hours, and you inherently save time, which translates to money, right? So I just used a full-time equivalent rate of $100, which is probably generous for a supervisor or an electrical engineer. So we've licensed this, and you have to sign a license agreement. It's copyright protected, and so that's because there's value here. And then you have options, and we've suited the license fee to small, medium, and large employers, and it's on the screen, right? So, and then after that, there's consulting support. And what we've defined is a bronze, silver, and gold consulting support. So we'll provide you with a quote for what this cost will be. And again, different levels. You can go fully self-directed under bronze, silver with some minimum consulting, or turnkey solution where we fully facilitate electrical safety steering committee meetings following a project execution plan process. So this program includes a project execution plan, the 4 phases. And again, you get all of that and can self-direct it, or we can help you with different levels of consulting. So we're trying to bring this to any size of company out there, small contractor, small widget factory, all the way to an enterprise-wide, manufacturer of anything, right? As an example, right? Sugar factories, right, across North America, toilet paper factories or paper good companies across North America, right? So this applies to anybody, 5-10 person electrical contractor. Guess who really needs this? Electrical contractors, right? So we've come up with a price point and an option here to help anybody get this program and use it to do everything I've been talking about for the last 2 hours. And ultimately, through this opportunity, we want to save lives, build confidence, right? That's our goal here, our mission statement. So this is a way to achieve it for employers, and I hope that short and long term, we can work with employers out there under Grace Technologies Expert Network and this electrical safety program offering.
Sure. So just as a closing thoughts, what I would strongly recommend as a call to action is go to our website, graceport.com, where you will find the self-assessment tool. So you can go and fill it out. It's free of cost. So that will trigger an email to us. So that will tell us that you are interested with the program or want to learn a little more about it, because I don't think this entire thing can be covered in 2 hours or just based on the discussions. So if you're really interested, go and fill out that self-assessment survey. We'll have a look at it, and then we'll have our insight sales reach out to you, set up a time with you. So Terry or myself, or we both will jump into a call to just understand what your status is or maturity level is given the electrical safety program and safety what you have at your workplace. And then we'll guide you through the rest of the process so that we can make it better. So all we're trying to do is just make it compliant and a solution-based approach and take it out, basically, not just bits and pieces, and we have a complete cohesive program in place. So that's kind of my final thought. Do you want to add anything to that, Terry?
Yeah, Bhanu, can you just, I think you have to let me share the screen again, or can you, can you see my screen?
No, you can share now. Yep.
Okay, so I'm going to stop sharing, and then I'm going to share just briefly here before we bring this to close.
Yep.
Okay, so I'm going to share screen again. Just bear with me here.
Okay.
Share screen. Let me know when you can see my screen. Can you see my screen?
Yes, I can.
So you just mentioned it, and I've just brought it up. This is graceport.com, expert network, right? Develop and implement an electrical safety program that will save lives, ensure confidence and consistency across your enterprise. That's what this will do. And then we've got the self-assessment, right? And then there's a video here of Bhanu and myself introducing it and launching it in the fall. And then there's some really good background information, and there's a data sheet, right? And then our process, discovery, tailored plan, implementation, training, right? So this is unbelievably, in my opinion, awesome. Again, I've been blown away by Grace, the professionalism, the people that have been involved here to support this new initiative. Amazing company, amazing people. You know, I got to thank Phil and Drew Allen and everyone at Grace. So this is unbelievably credible, and we have a data sheet that can be downloaded, right? So, you know, again, like I said, get organized, make a plan. We've got some FAQs on here. This document's amazing as well. It'll help you do that gap analysis we're talking about, right? So it's all on here as well, right? Again, some really cool avatars about, you know, what this is all about, the benefit, time loss, training and other costs, loss or damage, right? We're focusing on the hierarchy of risk controls because ultimately this program will ensure, amongst a laundry list of things that it'll do for you if you implement it properly and audit it, ensure that these controls are leveraged appropriately. And again, ultimately get back to what we want to achieve, right? Which is, you know, clarity and confidence and save workers' lives. All right. So, Bhanu, I just wanted to point out, you know, this on the website at graceport.com, the self-assessment. If you reach out into Grace, we can provide you with some other documentation, that development implementation checklist. If you contact Grace, we'll send you that 9-page development implementation checklist, and you can go off and do your own audit, your own self-assessment independently of us. And then we'd really like to help you with this solution. And Bhanu, again, I appreciate everything that Grace has done. I appreciate you organizing the live streaming today. And we're here to help.
Sure. I mean, thanks so much. Thanks again for doing this for our audience. And definitely, I'm sure that the audience will greatly benefit from this program. And if you have any other questions around electrical safety or something that's specific to your facility, which you want to open up to us, you can drop an email to me or Terry. You have our email addresses on the website, so you can just drop an email. We're more than happy to get on that one-on-one conversation and help you guys out with any kind of solutions that we can come up with for you. And if you don't mind sharing this, just feel free to share this video. This will be live stream right now on LinkedIn, YouTube, and Facebook as well. If you come across this video, please feel free to share it to your network and let them just go through that. And I'm sure they will pick one or two things from this that's useful for them.
Thanks, Bhanu.
Thank you so much, guys. Thank you so much for attending the.
Thanks, everybody. Take care. Have a great day. Be safe.